In this section, we're going to talk about series. We've already gone over this last year, so most of it is going to sound like a review. So remember, the difference between series and sequence is that series is a sum of all the numbers in the sequence. So we have two kinds of series that we're going to talk about, and that is arithmetic and geometric. And in each one, we have finite series. That means you have a limited number of things that you're adding, and an infinite series, which means you're going to add an infinite amount of numbers. Now, of course, in arithmetic series, there is no infinite sum, because if you keep adding a number that is bigger than itself or adding a number that is smaller than itself, eventually you're going to get to infinity or negative infinity. So it's just not very interesting to talk about those numbers, so we don't have infinite series for arithmetic. Okay, now I'm gonna just kind of go through the formulas really quick, and then we'll talk about how to apply the formula. So first, we're gonna talk about the arithmetic finite sum. So finite series. So if you have a sum of n numbers, the formula is n over 2 times first number plus last number. So we have this here. Arithmetic series is the sum of arithmetic sequence. Okay, and geometric series is the sum of geometric sequence. So in geometric series, we have two kinds of series. One is called a finite sum. The finite sum, again, is you're going to add up limited numbers of things. So the formula is a1 times 1 minus r to the n over 1 minus r. So it's kind of a complicated formula, so we're going to talk about applying the formula carefully. In the infinite series, first you have to check that r, the absolute value of r, is less than 1. So what that does is saying, is the next number after the previous number smaller than itself? If the number keeps getting smaller, then it's going to converge. So this we call converge. If it converges, we will have a sum, and the sum is a1 over 1 minus r. But if that absolute value of r is greater than 1, then it's going to diverge, and when it diverges, there's no sum. All right, so let's go ahead and practice finding the sum of the series. So let's look at A. The first thing you're going to do is you always want to determine what type of series it is, and it's very apparent this is arithmetic. You're adding a number to get to the next number. So once you realize or you find out what kind of series it is, you find out how many numbers it wants you to add. So from 1 to 80, that is 80 numbers. So if you want the sum of 80 numbers, you apply the formula that is n over 2, so 80 over 2 times first number plus last number. So this is going to be 40 times 81, which is 3240. All right, let's look at B. So let's change the number a little. Let's change 3 to 54 because 3 actually doesn't work. So if you look at the series, you can see that you're subtracting 7 every time. So this is going to be arithmetic. It tells you that the last term is 54. Well, we don't really know what term number that is, so what we need to do is find out the term number. What we can do is start with the explicit formula, which is an equals a1 plus d times n minus 1. We don't know what n number that is, but we know the term is 54. So that's equal to 117 minus 7 times n minus 1. We don't know what n is, so we're going to find n. So what we're going to do is take 54 minus 117. Negative 63 equals negative 7 times n minus 1. So divide by negative 7, you get 9 equals n minus 1. So n is 10. So that means 54 is a 10. So there are 10 numbers. And what we can do now is use the sum formula for arithmetic for 10 numbers, which is 10 over 2 times first number plus last number. So 5 times 171, we get A55. Okay, so I'm going to give you some hints on C and D. You're going to try those. So looking at C, you can see that this is going to be a geometric series because you're multiplying by 3 to get to the next number. And so what you want to do, same thing, you need to find out what term number that is by using the explicit formula, which is first number times r to the n minus 1, which is 98415. So find out what n number it is and then use the geometric finite series formula to find out the sum. So pause this video, give this a try. Alright, so hopefully you got to the point where you found out that n is 10. Now you plug it into the formula and you're trying to figure out a sum. So this is, this is just a formula, but you got to be careful when you're applying the formula. For example, you got to solve this part first, figure out what 3 to the 10 is, and then 1 minus that number, so do not subtract before, and then take that number times 5, and then divide it by 1 minus 3, which is negative 2. So go ahead and give that a try. All right, the answer is 1476.20. All right, let's go ahead and try D. Go ahead and figure out what kind of series it is, and then apply the same thing as before. All right, go ahead and check your answer. Okay, so let's go ahead and look at a actual word problem. A corner section of a stadium has 8 seats along the front row. Each successive row has 2 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? So if you kind of imagine that you have this stadium, so in the first row, you have 8 seats. Every row after that has 2 more seats. And then the top row has 24 seats. How many seats are in the entire section? So this is very apparent that this is going to be 8 plus 12 plus 12 plus all the way to 24. And looking at the series, you can see that this is arithmetic. So we need to first figure out how many rows there are, and then find the sum using the arithmetic sum. So go ahead and give this a try. Okay, please go ahead and check your answer. All right, now let's talk about infinite series. So we had just looked at everything with finite series, and now we're looking at infinite series. Infinite series means the sum of the series as n approaches infinity. So there are two possibilities of infinite series. First, the sum converges to a number. So as the number of terms gets larger, the sum actually gets closer and closer to that number. The second scenario is that the sum will diverge, and that means there is no definite sum. So arithmetic series convergence, as we have said before, it's always diverges. So no sum. In the geometric series, we said that it will converge when absolute value of r is less than 1. And so diverges is when absolute value of r is greater than or equal to 1. And let's go ahead and actually solve some. So for example, first one, find the sum of the infinite series. So you can see that this term looks like there is a pattern, which is true. And if you ask yourself, what number do I multiply to get to the next number? You can see that you're going to multiply by 0.1. And so this is a geometric series. And you can see that the absolute value of r is less than 1. So this is going to converge. If it converges, then we use the infinite sum. And how do you know it's infinite? Dot, dot, dot. That means it keeps going. So a1 over 1 minus r is the formula. So the first number is 0.1. 1 minus r. R is 0.1, so this is 0.1 over 0.9, which you can multiply by 10 over 10, so you get 1 over 9. All right, what about this next one? This is arithmetic, right? You're adding 10 every time, so this diverges. And C is a kind of interesting one. What do you think? Will it diverge or will it converge? Well, it looks like, your numbers keep going between 0 to 1 to 0 to 1, depending on which term number you stop on, right? And so it seems like it would converge. However, because it keeps oscillating between the two numbers, we call this diverge. You have to come to a number. You cannot forever go between two numbers. That is basically there is no sum, no definite number, so we call that diverge. Now let's come to another way of writing or asking someone to find a sum, and that is from using the summation notation. So if you remember this Greek letter, sigma, it means to add up something. Now, add up what? Well, this is basically adding up the sum of a of k, and a of k is our explicit formula, from, this is k equals 1 to n. So the term number 1 to however many numbers that you have. Okay, so let's find the value of each sum. So how do you read this? For example, this one, this is asking for the sum of 3k from k equals 1 to 5. So if you want to figure out what the series is, you can just say, well, the variable is k, and then the formula is 3k, and we're starting from 1 and then all the way to 5. So we're going to multiply 3 to every k, so this is going to be 3, 6, 9, 12, 15, and you ask yourself what kind of series that is. That is an arithmetic form series. And so we have the sum of 5 numbers, so 5 over 2 times the first number plus the last number. And then, let's see, we get 45. Do you have to use the formula? Of course not. This is just asking for the sum of these 5 numbers. Just, put that in the calculator and then you should get 45. All right, what about this one? Well, let's go ahead and write this out. So we have k, the formula is k squared. It says please start at term 5 and go all the way up to 8. So it tells me that to get to the actual number, you're going to square each one. So this is 25, 36, 49, 64. What kind of series is this? This is not arithmetic and not geometric. So we don't have a formula, but there are only 4 numbers, so we can add them together and we get 174. So not everything is going to need a formula. It depends on what kind of series it is. All right, so go ahead and give number 3 a try. This is kind of a trick question. You can see that the sum will oscillate between 0 and 1, but we're only adding 13 terms. And so the question is, by the time you add 13 terms, is the answer 0 or 1? This is going to end up at 1 because every one of them has a pair, but then term number 12 doesn't have a pair, so you end up with 1. All right, now let's go to a different kind of, section. We are going to rewrite the series as a summation notation. So it's not that hard. What you need to do again is first figure out, is this arithmetic or geometric? So this first one, you can see that it's arithmetic because we are subtracting 10 every time. And so the next thing you're going to do is actually write the formula, explicit formula. So 500 minus 10 times n minus 1. And for simplicity reason, we're going to simplify this. And then we're going to write the summation notation. So the explicit formula goes inside the summation notation. n equals 1, we always just say the first term is number 1. You don't have to start at number 1, but it makes things a lot easier. The next thing is you need to figure out what term number 10 is. Again, if you don't know what that is, put it in the explicit formula. Okay, and then figure out what n is. N is 50. And there you go. That is the summation notation. So go ahead and give number 2 a try. Pause this video and come back and check. All right, go ahead and check your answer. Okay, and then try number 3. Okay, since this one is infinite series, you would stop the term number at infinity. All right, last thing. This is kind of interesting. So you can see that this is a rational number. Rational number is anything that has either repeating decimals or terminating decimal. This one has repeating decimal. It keeps repeating 234, 234. So what we're going to do is write this in a fraction form, meaning, change it into a rational number. So you can kind of break this up. So instead of writing 0.234, 234, 234, you can just say this is 0.234 plus, now the next 234 happens here, and so we can say skip the first 3 numbers, so 0, 0, 0, 2, 3, 4, plus, and then the next 2, 3, 4 happens 3 more digits after that, so we're going to write 0.000000234, and then you can see this pattern keeps going, right? Now that we rewrote it, this actually looks just like the previous question, where this is a geometric series, and this geometric series is with an R of 0.001. Now, for me, it's very hard to figure out what this R is. So what you can do is guess and check. It's definitely going to be something 0.1. There's, something in there with a 1. It's just a question of which digit it is. So you can take the first number and then multiply by whatever you think R is, and then you have to get the next number. You can do guess and check that way. So it's asking for the fraction form, which is saying, what is the sum of this series? Well, this is the sum of an infinite geometric series that converges. And so you can just say it's A1 over 1 minus R. A1 is 0.234, because we're talking about this series here, over 1 minus 0.001. So this is 0.234 over 0.999. And if you multiply by 1,000, over 1,000, you should get 234 over 999. All right, go ahead and give the next one a practice. Come back and check your answers. All right, go ahead and check your answer. 3 over 11. I think I probably could have simplified the one before. I think 234 is divisible by 3. Actually, 9. It's divisible by 9. So 26 over 111. All right, let's go ahead and try the last one. So determine whether the series converges. If it converges, give the sum. Now, how can you tell whether the series is going to converge or not? Well, it will only converge if it is a geometric series. So then the question is, what makes it a geometric series? Very easy to tell. This function has to be an exponential function. So remember, exponential function means base to a variable, which this is. And so then what you do is you look at the base. Whatever the base is, that is going to be R. So R is 0.75. And so you ask yourself, will it converge? Of course, it will converge because absolute value of R is less than 1. And then so if it converges, we need to find the sum. So this is going to be an infinite series. So because of the infinite sign, so S is equal to A1 over 1 minus R. What you need to do to be careful of this is when you find A1, you actually have to put 1 in this formula. You have to put 1 in this formula to double check what A1 is. Please don't assume. So 3 times 0.75 to the 1 minus 1. 1 minus 1 is going to be 0, so this part is something to the 0, which is just 1. So A1 is actually 3. So 3 over 1 minus 0.75, 3 over 0.25, which is 3 over 1/4, so this is 12. All right, so let's try this one. You can see that R is going to be the base, so R is going to be -4/5. Okay, -4/5 is going to converge, and so find the infinite sum. Notice how the first term starts at n equals 0, so be careful of that. All right, go ahead and pause the video, come back and check your answer. All right, did you get the right answer? This one's a little bit tricky because, you know, in the formula we put A1. Well, it's not A1 that we want. It's the first number of the series that we want. And so if you look at the series, the first number happens when the term number is 0. And so we need to find A0, not A1, and then put that in the formula. So be careful of that. This A1 in the formula just represents the first, you know, whatever the first number of your series is. Please don't assume it wants A1 as in the term number A1. It's not always true. All right, go ahead and give this one a try. Hopefully this was a quick one. You realize that pi over 2, which is 3.14 over 2, is bigger than 1, so this is going to diverge. All right, go ahead and give this last one a try. All right, the answer is 2.